Welcome to Ask and Learn.
All right, so here we want to sketch the function y equals x over x minus 1. And so the first thing we'll do is we'll look for basically horizontal asymptotes, vertical asymptotes, and so forth, so we can get a good picture of the line. Whoops, I wrote line because I said line, horizontal asymptote. Okay, so horizontal asymptote is in the limit as x goes to plus or minus infinity of our function, and we want to see what we get. So let's take a look at for our function. And if it's polynomial, you'll get the same value plus or minus. If you have simple polynomial fractions, you don't have to worry about going to the infinity equaling anything different than going to the minus infinity. All right, so if I look at this, I'm going to infinity. And so what happens is that when I go to infinity, then just the high growth rates dominate top and bottom because x is getting really big. So that certainly dominates the numerator, and the bottom is denominated by the x as well. And you can see that fraction reduces down to 1. So I get 1. So we have a horizontal asymptote at y equals 1. And let's go ahead and draw that on there. It's not going to be dotted because I can't easily do dotted lines, but there it is. So we will have a horizontal asymptote at y equals 1. Okay, so next, let's try, how about vertical asymptote? Vertical asymptote. Okay, so vertical asymptote is basically whatever makes the denominator go to 0. So I can see right away that we're not, if I set the denominator equal to 0, x equals 1, and that is my vertical asymptote. I think I'll show you the calculus in a sec, but let's just go do that in because that one's pretty easy to do. So let's do our x equals 1. Okay, so that's our vertical asymptote. And officially vertical asymptotes would be limit as x approaches, say, 1. Of f of x, it does not exist. So our function does not exist as we go to 1, and we can actually kind of see what's going to happen plus or minus. You can see the bottom will go to 0, but the question is, are we approaching and will we get a positive or minus infinity? So let's go figure this out. Okay, so let's say I approach from the minus, approach 1 from the left. So I am going to look at this and approach 1 from the left. So let's plug in, just do this on the side. Let's imagine that we're plugging in negative like 1.1. If I go negative 1.1 over minus 1.1 minus 1, then I get negative 1.1 over, oops, I did the wrong thing. Let's fix that real quick. I want to be really, I did it for negative 1, so let's fix it and do it for 1. So let's say I'm at 0.9. That's just a little bit to the left of 1. I accidentally did negative 1 before. So if I'm a little bit to the left of 1, then I'm at, say, 0.9. Then I get 0.9 minus 1. So I get 0.9 over negative 0.1. You can say I'm already up at minus 9. So you can see I'm definitely going to be going way down, and that's going to be the one going towards minus infinity. So I can say this is minus infinity. And let's take a look at the opposite side. If I do limit x approaches 1 from the right side, then let's just plug in like 1.1 now. 1.1 over 1.1 minus 1, I get 1.1 over 0.1 or 11. So you can see that's going to be going to plus infinity. Okay, so that's kind of showing the calculus limit version of vertical asymptote. Okay, so just a kind of a note that we're going to minus infinity on this side and plus infinity on that side. Okay, so next thing, let's see if there are any zeros. So, or intercepts, let's see what's going on. So let's say if x equals 0, then y equals 0. So we definitely know our final result is going to go through the point 0, 0. And we can, maybe we'll just go ahead and check for max and min. Usually we can even already solve this as is. In fact, I would know that here I'm bound by my asymptotes and here as well. This would be your typical answer, but let's go ahead and prove it. We want to prove that there are no maximum values, and we can prove our concavity. So let's do that real quick. I'm going to need to clear the screen, so I'll be right back after clearing half the screen. All right, so let's go ahead and find the derivative. We'll do quotient rule. So derivative of the top times the bottom minus the derivative of the bottom times the top, all over the bottom squared. And let's see, that gives us x minus 1 minus x. Oh, that's nice. The x is canceled, so that's helpful. So I get minus 1 over x minus 1 quantity squared. So we know that critical points are when that equals 0 does not exist. So we have a D&E case. So basically we have a critical point when y prime does not exist, and that occurs when the bottom goes to 0 or x equals 1. And notice that that fits with our vertical asymptotes. That's cool. Okay, so let's look at second derivative. Well, so therefore, if I were to do a sign chart already, let's just do that. Let's do this all the way. So if I were to do a sign chart with x and y prime of x, we only have one critical point at 1. This is a D&E case. And if I were to make x really big, then my derivative is negative. And if I were to make x really small, I get a squared, so I'm still negative. So you can see that I do not have a max or min. I don't have y prime going from plus to minus or minus to plus. So that's kind of a proof that I see no maxes or min here. Because we're approaching asymptotes, we don't get a max or min. All right, so we're almost there. Let's check concavity real quick, and then we'll have solved everything. So if I take the next derivative, first derivative, by the way, I can rewrite as minus x minus 1 to the minus 2. So I can do power rule, so I'll get 2 x minus 1 to the minus 3. Chain rule is 1, so I get 2 over x minus 1 cubed. Same idea, this will not equal 0. And I do have a D&E case at x equals 1 again. If I were to do a sign chart this time of the second derivative, then if I plug in, I notice I always get positive because I have a squared on the bottom. There's nothing I can plug in that will give me a negative. So notice that gives me, oh, my bad, it's cubed on the bottom. I wrote it sloppy, and so I just have to correct what I just said because this is indeed cubed. So if I plug in a big value for x like 2, I get a positive value. But if I plug in a smaller than 1 value for x like 0, I will get a negative. So this is negative. So basically we have on the left concave down, which you can see is true here on my graph. And on the right past 1, I do have concave up. So very cool. That we can analyze it all the way through. So anyway, hopefully that helped. Have an amazing day. See you next time.